So I want to thank everyone for joining us today, along with our guests from Metrologic. We've got a lot to show you, so I won't take too much time here at the beginning. My name is Ben Reese, DCS Marketing. I'll be your moderator today. If you have any questions throughout today's event, please use the question section of your interface to send those in as soon as they come up so you don't forget them. We do have a Q&A session at the end, tucked aside, that we'll be able to get to all of those. All right, let's get underway. If you have any audio issues, please change from your computer audio to the phone call and then back to computer audio, and that'll reset your audio connection. And in addition, I want to remind everyone that today's event is being recorded. So you'll receive a recording of today's event and a follow-up email with some additional resources. And those additional resources will include a previous webinar that will cover the 3DCS optimization of the GD&T and PMI that's going to be used to power today's inspection program for the CMM. All right, this time I'm going to be passing the presentation over to Alex, our guest from Metrologic, to give us an introduction and introduce our presenters. Get us underway. All right, Alex.
Great, thank you, Ben. Here, Trev, if you want to move to our next one. So first things first, so Metrologic and DCS, we're both part of Sandvik Group, and one thing that we really care about is that at the beginning of every presentation, we just do a quick thing on safety. It matters, all this great technology we work with, we do it all for the people at home, for our lives at home. You know, just know where your emergency exits are, make smart decisions, and just, you know, be safe. My name is Alex Clement. I'm the key account manager for Metrologic Group in the US. And then Trev, you're muted.
Yeah, figured that out once I started talking. So I'm Trev Questenberry. I'm a senior applications engineer for Metrologic Group. I've worked at Metrologic Group for a little more than 10 years. Before that, I worked as a quality and manufacturing operations manager. And then I started out, my first job was a manufacturing engineer.
Hi, I'm Bonton Fidelis. I'm the application engineer for QDM suite of products. I've been with DCS for the past 3.5 years. I've been a dimensional engineer in my past jobs. I've been with Stellantis and GM before. So that's pretty much about it.
Yeah, just to cover a little bit about today's agenda. So we're just going to do a quick introduction to Metrologic Group as a company. We'll kind of talk a little bit about what we do with Metrologic and DCS, and then talk about 5-axis CMMs, what they do, where their value is, and then what that increased throughput, where those throughput gains you can get out of that technology, how that data is better and more useful, and then what we do with that flexibility in our programming with Metrologic, and how we program with Metrologic, and then what we'll do to close that loop with our relationship with DCS. So just to start, Metrologic, we started in Grenoble, France in 1980. We're a global software company. We have resellers and local offices all around the globe. Our US headquarters is located in Wixom, Michigan. And we've been working with 3D measurement from CMMs, from portable devices, and even with robotics for over 43 years now. And part of it is with Metrolog, we offer direct integration to DCS. Since we're sister companies, we get that direct line of communication and a little higher degree of collaboration. So we'll directly connect to QDM and 3DCS for that seamless process integration for either your dimensional, more in-depth dimensional and tolerance stack-up analysis, or for your SPC needs there. So with Metrolog, we offer a pretty full suite right now. So we start with Planner. Planner is a tool where you can create your GD&T and PMI. You can build out a inspection plan and then be able to disseminate this down to your lower processes. And one of their tools we use that is Silma. So Silma, we can intake that data. We can intake your PMI from other platforms like CATIA, NX, or if you're using QIF. And CILMA will have a full cinematic model of your CMM and of your hardware, and this allows you to have really, really accurate offline programming of your routines and testing of your programs before you ever have it touch the floor. And then with Metrolog, this is what's going to connect to your hardware. Metrolog is where you're going to be on the CMM, running the CMM, using that program you made in CILMA. You can still program in Metrolog and then do the analysis of your parts in there and then push that out. And then we also have our manager suite. And our manager suite is actually a suite of integrated products into Metrolog and CILMA, where we have an OEE tool that's built in there. We have an iViewer that's free with a license of Metrolog that you can have somebody look at the measured part with that data in there. And so all of this is a single software, and we just utilize different environments to allow you to have different tools available to you. So if you're trained in Metrolog, Learning Planner is maybe a couple more commands. If you're trained in CILMA, you can run Metrolog right off the bat. There's no difference in the software experience, just the environment. So in Metrolog, we heavily have been working in 5-axis technology from Renishaw. So we have a direct connection to the UCC controller. We're not going through like an interpreter or anything. We speak UCC to the UCC. And when we're doing this 5-axis technology, we allow the head to move dynamically in reference to the CMM coordinate system. So instead of a 3-axis CMM where you'll stop, have the head change orientation, and then you'll start your navigation again, your head's able to constantly move and constantly measure while the CMM frame moves, or help reduce that movement in turn to help up your accuracy. And with this, you start to see this really great reduction in cycle time. That the 5 seconds it takes for a PH10 head to adjust an angle, that stacks up when you have 15 angles, 20 angles, 30 angles in a program. And then your programming gets easier because you don't have to figure out, how do I like align this part and approach this. And then the last piece with it is there's kind of 2 routes you can go with it. There's a touch trigger tool with a PH20 from Renishaw, or there's a multi-sensor scanning head that's the Revo 2 is pictured, that's available to utilize, and those are all available to program in Metrolog and CILMA. So with a PH20, this is infinite positioning, infinite indexing here. So you can rotate that B axis as long as, until the cows come home, it's infinite there. And then your A axis, you get that 115 degrees plus or minus there. And what this is really doing for you is you're reducing the stylus changes. So you're not having to change like angle, the head angle every single time you need to like get to a specific item. And then you also get this nice gain where your fixturing doesn't have to be perfect, or you might not even need fixturing, because the PH20, once you're aligned into the part, is going to change all of its moves relative to that coordinate system of that part. So you get this nice gain and some simplicity in your programming process. And a nice piece of the PH20 is you're using the established TP20 module. Those are everywhere. They've been using them on CMMs for years and years. And they're highly available, highly easy to find, and very easy to use. And then with a Revo, so this is a multi-sensor head, and kind of going from left to right, we have our traditional tactile scanning, and then we'll have our vision probe, which can do all kinds of really great things depending on your industry. And then we have our surface finish module. And then the last piece is the ultrasonic thickness sensor. The fringe probe, we do support the fringe probe. Renishaw recently discontinued this, but if you do have that fringe probe, we're able to use that and collect that data from there. And the gain you get with the Revo is you take all these different devices that would have been doing a lot of different work and different operations for your quality process, and you bring them all onto one machine, and you just get this very high precision, high volume method to collect data, and you're maximizing your machine's capability of measurement. You're not just limiting your CMM to take 3D points. You're now opening it up to tell you, what's the condition of the surface, or how thick is this casting in a section I could never probe into. And this is just a huge tool for your capability and your productivity in your quality lab. So when we look at a 5-axis CMM, one of the gains that you get is through your throughput. So with a 3-axis CMM, normally you'll have the head orient itself, and then you have to calibrate that stylus with that angle to be able to use that in your program. And so normally once a day, once a week, depending on what your process demands and your quality demands are, you have to run that calibration routine. And every time you add a probe, you're adding 5-6 minutes to that. So I've heard of routines taking hours to calibrate all our heads just to start running and measuring these parts, where with 5-axis CMMs, they'll do, when we calibrate that stylus, it uses an inferred calibration, and this calibrates all of your angles all at once. And so these are all available for you to be able to use. So that calibration time for a really complex part or a really simple part, it's the same with the PH20 and the Revo. And then with the 3-axis CMM, yeah, you'll up that time. And then with a 3-axis CMM, you actually get an accuracy uncertainty introduced. So every single point you take on the 3-axis CMM, the frame manages the data collection, and the probe is really just feeding back what the deviation is from perfect there. And so your frame moving, there's little dynamic issues, a little bit of flex, a little bit of play. Now it's very, very small, but it's still there. And with the 5-axis CMMs, your frame is still, and so the readings are more absolute, and then you start, you increase that accuracy and that reliability. The PH20 does this through head touches, and the Revo could do this through a myriad of different methods, either through a still measurement or other strategies. So this is a video, this is available on our LinkedIn. If it's not playing for you, just ask us for the link. We'll be more than happy to send it to you. And this is running, the bottom we're running the PH20 in a 3-axis mode, and the top we're running it in a 5-axis mode. And it's just a comparison to see how dramatic of a difference this is. Time studies really do vary. You can get 30 to 50% generally. We've seen higher, we've seen lower, depending on what the part is. A more complex part is gonna get you a higher yield and cycle time savings. A very simple part that's flat, you might not see as dramatic of a gain, but you should still see a gain. And then with that reduced calibration time we just discussed, that increases your machine availability. That hour you were calibrating, that's an hour you can run parts, and that's an hour that machine's available to tell your CMM or your CNC processes or your other processes that they're still accurate. So you'll see our 5-axis finished up, it's at 26 minutes. And 30 minutes in, we're still kind of running for the 3-axis device. We can move from there, Trev. Yep. So, and then in Metrolog, and this is available with Metrolog or CILMA, is we have a very CAD-driven programming platform. Now, you can program without CAD, but you'll get the most power in our process and our capabilities with your CAD. And so we're capable of taking these features that you've built in your PMI, or if you're using QIF, we can bring these in, and then we can also visualize how we're going to collect that data. And that visualization is really powerful and really helpful for a 5-axis process where you have 2 angles of abstraction you now have to think around, where here, we're visualizing, those more yellow lines is kind of where that probe shaft is going to follow, and that red dot's where the head is going to sit. And that kind of helps us understand how we're going to navigate this, how we're going to protect our machine, how are we going to measure this part efficiently, and that's through a lot of the visualization tools there in Metrolog. And then we have very readable and pretty easy to edit programs. So that's really important on the other side. When you have multiple programmers, or you have a programmer who's moved to another role and you have someone coming in, the language that Metrolog uses, our MGProg language, makes it very easy to understand what you're doing and what you're intending to do. And so reading here, we can just look and say, hey, we're defining a probe and picking it out, and then we're going to set what speeds we want, and then we're going to pull an alignment we had, and then we're going to move somewhere and start measuring features. And that's a really nice piece when you get maybe some other software that it's a little bit more abstract. There's a little bit of a different understanding and how you get the most out of that. There with Metrolog and that readable routine, you get a predictable outcome. And then last piece, we have a lot of really great tools. One of our great tools that we have is collision avoidance. So we can automatically avoid collisions for you on your behalf to help navigate that, and also to help save you money if we're crashing your part. If you're crashing these probes are not necessarily cheap. That cost can stack up, and so with some of the built-in tools there in Metrolog and CILMA, we can help powerfully control your process and help make sure that everything that you're doing is benefiting your end use, which is accurate measurements that are consistent, reliable, and also that are going to damage the machine. And then one thing we'll also do is we're very visual with our reporting. So here we have just a view of a truck cab and all kinds of stickers indicating what features are where and what condition these are in. And these are great for helping your downstream processes understand exactly what they need to understand to be sure they're maintaining their process correctly and make sure things are in spec, or when they're out of spec, why and how. And then this is also available with like customizable tables that can be put in there. So we can take all these stickers and put them in a quick table, so then you can have another reference aside from this image. And a feature I really like to touch on is our detailed view, or is through our GD&T interpretation. So this is with any feature, you just right click on it and hit detailed view, and we'll show you the GD&T that you inputted for this, and we'll help you understand the tolerance zones and ultimately help your stakeholders in your process. If your stakeholders don't understand what a line item, when it says, hey, we have bidirectional position and it's out, how do you express that? And this is a great way. Everybody doesn't have to speak our alignments. Everyone doesn't have to speak every single piece of GD&T. Instead, we can all speak the same language, which is the part we're making, and help that understanding of what's going on, why is it out, how is it out, how do we fix it so that we can get our processes in control. And then with Soma, so Soma has lots of productivity gains. There's lots of nice pieces about Soma. So one of the key pieces is you can simulate any machine. And with that simulation, we're very, very confident you can do any kind of programming anywhere in the world on that machine and then send the program and run it. And this is also a great tool, because when you're programming, instead of sitting at the machine for a few hours and getting your print figured out, you can sit at your desk and program that, and your machine goes and runs parts and keeps your processes running while you get ready for this new part to come. Ultimately, Soma is helping you save that time. And then another piece, I know I've harped on this, but you're avoiding downtime from damage or from crashing the machine. You know, when you crash the machine hard enough, you need to reset, send it home, maybe even recalibrate the probe. And that's all time that you could have been measuring parts, but you're not spending measuring parts because you maybe crashed your machine, or even worse, you've damaged some of your probes on there, and even worse than that, maybe even damaging the frame. Here you can prevent all that. You can crash it safely and then correct that and help make sure that your throughput is up. And then here we'll move to a demonstration with Treb.
Thanks, Alex. So I'm going to switch over, and we're going to take a look in our Soma software. So Alex earlier reviewed, we have different environments that we can work in within our platform. So Soma is our offline programming software. So the first thing we're going to take a look at is this is the part that we're going to be using for our demonstration today. So this is a gear housing. And the first thing we're going to look at, Alex talked about earlier, how we can utilize the PMI that's in the CAD model. So the PMI that's in the CAD model is our evaluations and our tolerancing. So in our balloon numbers or characteristic numbers and our datum. So we can see here, this CAD model is created, and the designer added everything into our 3D model. So we have our true position callouts. We've got some perpendicularity callouts, concentricity, flatness. Our datums are all defined on our part, and everything is ready for us to utilize in Soma here. So we've got all this information contains everything about the evaluations that need to be done, the tolerances that need to be applied, the features that need to be inspected to evaluate the part. So we've got all this information from the designer, and we can quickly and easily check these or take a look at these inside of Soma here with what we call it scan GD&T. So we can take a look at our model. We can see what callouts, what characteristic numbers are assigned within our CAD model. So we can see everything kind of that we see over in our 3D model over here. We see summarized in this table here. And then we have a functionality that we call inspection plan collector. So right now we don't have any what we call inspection features. So we don't have any features in our inspection features database here. All we have is our CAD model. So we have the ability to utilize what we call inspection plan collector. And when I click this button here, I'm going to see it's going to generate all the features that are associated to our CAD model's PMI, all the datums, all the evaluations, everything's automatically can be created for us just clicking this one button. So once I click this button, I'll see this window here populate where the features are listed here. So I click this here, I see there's features that are created, there's planes, there's datums, there's cylinders, there's the datum reference frames are created. So any of the datum reference frames that are in our evaluation here to do any of these evaluations are automatically created. The GD&T evaluations that are in the PMI are automatically created. And everything that we need to evaluate this part has been defined. So right now, these are just defined features. We need to still measure the features to complete the evaluations, but we can see quickly, all the features that need to be evaluated are automatically created. We don't have to look at this call out and figure out which features need to be part of that. If we have a position call out that has seven holes, we don't have to figure out which 7 holes those are by looking at a drawing or trying to look at the CAD model and go back and forth and figure out what they are. We've automatically consumed or pulled those out of the model. We kind of go back and look at our population here in our window. And as we continue through the process, these are updated. So right now it's saying it's partially utilized because we've only defined those. So that's part of how we can utilize things to be more efficient and use the information that we already have that was already created to quickly make our process so we don't have to create everything from scratch. So we're going to switch and take a look at doing programming with the 5-axis. So I've prepared a simulated CMM here. So I'm just going to load the simulated CMM here. And we'll take a look at what we have here. Let me run it down to this section here. So this allows me to connect to, or to open the link to the QDM. I'm not going to open this because Bonton will be showing that later. So I'm not going to actually open the QDM in the web browser right now. I'm going to say no to this. And then it's going to load my cell here. And what we see here is we've got, sorry, the wrong program here. Open this one here with the actual PH20. So let me run this as a PH10 3-axis head that Alex was actually talking about earlier. So this works out here. So it's the 5-axis head that we were looking at. So this is the PH20 head. So we can see that we can load in our simulated CMM. This is one of the CMMs that we actually have in our headquarters. So we have simulation for the CMM. We have a simulation for the heads. The head, we build the head in, we build the tool in. Everything functions just like it does. It's a digital twin of what we actually have here. So I'm going to rerun the stuff that we ran a second ago. And then we've got our model here. So we've got our part here, and we've got our head here. Continue running this to this spot here. And then we can see, as we're running things in the program, so this is just a movement or a 5-axis movement. I can see the CMM's moving, the probe head's moving. And now we'll just take a look at how we can do that programming and control those movements here. So I'm going to just show how we can do the movements of the head. So we can move the head and the CMM in a 3-axis mode just by dragging these indicators here. We can also type values in this window as well. And then if I hit the shift key, I can also control the rotations of the probe head. So I can see, we can rotate the A and the B angles. So that's what Alex was talking about earlier. So this kind of indicates the way the A angle moves, and then the B angle rotates around the quill, around the pivot of the head here. So if I hit this shift key here, I can see that I can grab this red indicator and I can rotate around the A axis or the A joint. And one thing that Alex talked about earlier is that it's infinite orientation. So there's a couple things that benefit us on that infinite orientation. So with a standard style 3-axis type CMM head, usually that's limited to 7.5 degrees or 2.5 degrees or 5 degrees. But in this case, we have an infinite amount. And when we do the calibration, it calibrates all these infinite angles. So we just do that one calibration and can do any angle. So based on any orientation a hole may have, so when you get into some complex 3-dimensional parts, make the holes not exactly at a 7.5 degree increment, this will allow us to orient the probe head exactly at whatever orientation the feature has. And then we can do the same thing with the B-axis. So we can rotate the probe head around in the B-axis. I can just grab this indicator and drag it around, or I can type in, the actual values that I want here. If I want like rigid values, I can type those in. And then we can see, I can see a preview of the move if I'm making the movement myself here. We can see a preview of how that move would be created. So that's how we can kind of create moves ourselves. Alex showed, we can utilize some other functionality to help us make the movements around the part automatically as well. And then let's take a look at how we create a 5-axis type measurement inside a cylinder inside of Metrologic. So here I'm just going to define a cylinder. So I think this hole kind of in the middle, it lets us see a little bit easier kind of how the measurements went. This is a larger hole. So I'm just going to define that just by clicking right on the CAD. You can see when I click on the CAD, it populates our information for the feature there. And then if I go to the measurement, then I can see I have different measurement methods, radial, axial, helical, different methods we can use. But this is where we can see what Alex was talking about earlier. So we can see the movement of the head. So that's what this kind of peach colored indicator is. This is how the center of the head is going to move into position. And then we can see this is the center of the pivot point of the head when it's rotating. So this is kind of how it's going to move down here. And then we can see the actual how it's going to move into position and do the actual touch points of the cylinder here. So let me change this so it's closer to the center here, and then we can see we can do two different paths there, and then we can easily change. If I want to start at 0 degrees, for example, or if I want to change the number of probing points, all I have to do is just click right in there and change those values there. And also change the depths easily by just clicking on these indicators here. So we can change the measurements. We can see kind of what the measurement's going to look like before we even kind of do the measurements here. And then to do a measurement, all I have to do is just click OK, and then we'll see that everything's going to kind of move right down into position and do the probings. So I can see how it's going to move down in, and then we can see there's a good representation of, when we do that measurement, you can see the quill kind of stayed in that one position, and then the probe head kind of just rotates around the B and the A angle. So that allows it to, the things Alex was talking about earlier, that helps with speed, that helps with, the accuracy, because we're not moving the quill when we're doing the probings. We're actually only rotating the A and B angles of the probe head. So I'll just do that same kind of measurement just one more time so we can just watch the probe head move again. So I'm just going to select that, go to my measurement, and then we'll just watch this time when we watch the measurement, we'll see that the quill's really, once the measurements start, the quill doesn't move. It'll probe the first set of points at one depth into the hole, and then it'll move towards the inside of the part a little bit, and then the quill stops moving, and then it just rotates around to the measurement again. So I'll just hit OK there, and we'll do that measurement again. So it's kind of a good representation of kind of what the 5-axis functionality kind of looks like, and how it would be a little bit different than what a typical 3-axis CMM would be. So I've got a program that's already set up to measure the part in 5-axis mode. So it's going to measure some planes, the same planes and cylinders that we were just looking at a little bit ago when we were consuming the PMI. I've already gone through and created a program to measure those features. And so we're just kind of take a look at that program running, and we'll explain what we're seeing while that program's running. So I'm just going to start this program running. And then we're seeing, one thing to notice is as the CMM's moving, the head is also rotating at the same time. So we can see here, with the planes, we're minimizing the movement of the quill. And then the touch probing, when it's actually doing the probings, the quill is not actually moving. So it'll kind of move into position a little bit, and then it'll touch off on the planes. So on this side of the part, we're just measuring planes on the back side of the part. So it's doing touch probings on the planes. And then the CMM's going to move around to the other side of the part. And now we're going to do, I think there's a couple more planes we're going to measure, and then it's going to do some hole measurements. So now we can see with all the hole measurements, it kind of moves into position. All the touch probings are rotating the probe head only. And you can see the holes are really where you're going to see a big gain with the PH20. You're going to see, and that's what the video we were looking at earlier, that's where you see a lot of the gains. That part's a lot of holes, and that's where you can see a lot of gains, because the CMM itself doesn't have to accelerate and deaccelerate every single probing point, with the frame moving. So we've got a couple more planes and a couple more cylinders that we're going to measure here, and then we'll start to take a look at the measurement results that we get and the evaluations and the detail views that we can see from our measured features. So got one more feature here, and then the probe just returning back to the starting position. So right now I'm going to we're going to take a look at this evaluation here. So this is the detailed view that we were talking about earlier. So this is stop this just for 1 second. So this is a true position of 7 holes. So we've got 7 different holes that are part of this true position call out. So we've got a diametrical tolerance zone. We've got a tolerance. We've got a data reference frame, and we can see, typically when we do an evaluation like this, we just see the result. We can see the overall result. So if there's 7 holes that are being evaluated, we just see the result of the highest evaluation in that group. And also maybe we just see like the XY direction that feature maybe is off. But what we can do with our detailed view is that we can also show the individual result of each individual evaluation. So we can see, this is all we see, and that's associated to the highest evaluation, which in this case is cylinder 5 is our worst position result in this case. But we can see the actual individual results of all the other features. So this could be useful, especially if this was out of tolerance. We would be able to see maybe 1 hole's out of tolerance, all the other ones are in tolerance. So we just need to work on this 1 hole, and it's easy to see that quickly. But the other thing that we can see is that if you look a little bit closer, we see that this tolerance zone, this 0.05 millimeter diametrical tolerance zone, we can see that that's graphically represented here by this green cylinder. So we can see, if we zoom out, we can see the cylinder apart. We can see this, we exaggerate this, so we can actually up here. So we can actually control how much we exaggerate this. If I put this down to 1, then we'll see that that's actually the real size in relation to the actual part. So this is a 1-to-1 representation of what that tolerance zone looks like on the part. But we see if we show that as a 1-to-1, it's kind of hard to tell really what's going on. So that's why we exaggerate the tolerance zone, and you can control how much exaggeration you want to be able to tell kind of easier what's going on there. So we can see graphically the tolerance zone, but the other thing we can see here is the deviation of this hole at the top and the bottom here. So we can see, is this off at the top or the bottom? What orientation does the actual axis have? So we can see that the orientation of this hole from top to bottom is this white line that's in the middle, and we can look at that at all our features. So we can quickly, go around, we can look at the part. We don't really have to even worry about the coordinate system because we can see it like this. So the coordinate system is valuable, so we know exactly how much it's off in X and Y, but we can visually see which direction it is in relation to the part. So it's easier to understand, instead of having to explain what the coordinate system is, which direction the coordinate systems are, and things like that. It's easier for somebody that's operating the machine to look at the part and say, okay, this is off this direction or that direction. That kind of circles back to the manager suite that Alex was talking about earlier, that we have another product that's called iViewer that's exactly the same. It opens exactly the same as what we see here, and we can zoom this around. We can change the exaggeration, things like that. We can go through different views of evaluations, but anybody can install that and open the results file that we're looking at right here in the same exact way. They just don't have the functionality like programming and things like that. It's just working more just directly with the results. And it's very powerful to be able to, instead of just looking at if this was just a PDF report, it would just be a stagnant view, but we can actually open that up and take a look at that. So let's go back to the program. So the last thing that I want to take a look at here is how we connect to or send the results to the QDM. So which in our program is just here, it's handled in this export block here. So the way we do our data connection with our QDM is we have what's called a direct connector. So this allows us to connect directly to the QDM server and push the data to the correct location into the server instantly. We have a lot of different other formats. We can export out text files. We can export out directly to a database if we create the mapping. We can export out to Excel. There's a lot of different QF formats, things like that we can export out to. But what we do with QDM is we have what's called a connector. So we connect directly to the server. So we connect directly to QDM. And we'll just take a quick look at this. So I won't get too far into the settings or anything. But really what we do is we have the login information for the QDM, and then we have some program or part information about where this data goes into the QDM server. So we got the data source, we got a part number, which we're just using a generic Metrologic demonstration information here, and then we got what part program is running, and then what the ID of the program is. So this is all kind of information that needs to be along with the part, and then there's actually individual information that's also sent that's part of the individual inspection. So there's things like serial numbers and job numbers and device information and things that are also being created when we're running in this in Metrolog, and then connecting and sending the information to QDM. So we just took a look at the part, one part run inspection, but when we get to QDM, we can take a look at what does that data look like statistically, or can we see like more information if we look at more than one part's data and things like that. So now I'm going to turn things over to Bunton, and he's going to take a look at or show us the QDM.
So as Trev mentioned, we have a direct connection between Metrologic software and the QDM Web QI system. So this is the homepage of QDM Web QI system. So I have a login.
We're not seeing yours. There it is. Okay. Sorry, it just took a moment for your screen share to load. We're all set.
Okay, sorry about that. So this is our home screen of QDM Web QI system. So each person has their own login. We have a login information over here. So as I mentioned before, there is a direct connection between the Metrologic software and the QDM Web QI system. I can come over here. So this is the home screen. I have a certain set of favorites. So the part that Trev was showing before was the MBK block. So over here, I have the first section as my select data, the metadata as we call. We have company, product type, division, and this could be customized for each customer or user if needed. And we have the sample size over here, the number of samples that were uploaded within the time range. And we can use, let's say, the last 30 or last 80 or however the user wants. So let's say if I am the dimensional engineer or the quality engineer, I can come over here on a daily morning basis, log it into my system. And if this is a part that I'm interested in, I can look at the samples that were uploaded from the Metrologic software. So now if you notice the part that Trev measured, he directly uploaded that sample into our system, and that's the sequence name. If you notice the measured date and time, it's 11:30. So he just measured that part in the Metrologic software, and now it's directly uploaded into the system. It's almost instantaneous. So if I'm the quality engineer and if I want to see the samples that were measured yesterday, so let's say if I can select those samples that were measured yesterday. So these are the samples that were measured yesterday, and I have 10 samples selected out of the 80 samples. I can, even before looking at my detailed reports, I can quickly see the PIST scores of the last 10 samples. So I have a PIST score of 91% for the first few, and then it increases, and then it drops down, and then it increases again. So it gives you like a very high level overview of what the part is doing on a very high level basis. But let's say if I want to do a detailed level of analysis, I can quickly select those 10 samples, and I can click the generate report option. So if you notice, right, like all these clicks are almost instantaneous. It took me less than a second to load these pages. We have an option called interactive report, and we can click the generate report option. So if you notice, what I'm trying to do is I'm just trying to generate a report for the samples that were generated yesterday, or the parts that were measured yesterday. So now I have a detailed report. This report was created using our other QDM suite of product called QDM Analyst. So I have my custom report created for the features, for the whole of features that Trev was talking about. So I can quickly see my diameter run chart for yesterday's sample. But then if I notice over here for cylinder 6 or the hole 6, I have samples that were running towards nominal, and then all of a sudden I have a few features that are running out of spec as well. So as a dimensional engineer or quality engineer, I want to know like why it ran out of spec in the first place, and then it came back to nominal. So did something happen in the shop floor yesterday, or something that the quality engineer or the dimensional engineer should be aware of? What I can quickly do is I have an option over here called a show chart, and I can click this chart. So what it gives me is something called as quality notes, or what we call as Q notes. So the dimensional engineer or quality engineer, let's say if someone from the shop floor, can come into the system and see if it's running out of spec, and if they have like a root cause or some information that they want to enter, they can enter into the system what we call as quality notes. So now if you notice, an action item was done yesterday, meaning the pin was damaged, and someone noticed the pin was damaged, and then they also changed the pin, right? Like if you notice the note that's above this particular Q note, the pin was replaced, and they have also given an instruction saying monitor the next few inspection programs. So now as a dimensional engineer and a quality engineer, so now I feel much more relieved knowing that something happened in the shop floor, and root cause was also done, and an action also took place, right? So most of the times this information is not shared with different teams, but now with QDM Web QI system, this information is shared from, let's say, from an operator to a quality engineer, or to a dimensional manager, or even to a director at the plant level, right? Like, so anyone who has access to the QDM Web QI system will now be able to access the quality notes. So let's say if there was no quality notes added, right? Like you can also add a Q note, what we call as a Q note. Like you can come over here and click that particular feature, and we can also send an email to your fellow colleagues who are part of the system. So let's say if I want to select a couple of people here, I can send an email for that subject. I can say, let's say if as a dimensional engineer, I am working on a root cause or a green belt project, then I can type in some root cause analysis, right? I can say, you know what, monitor this feature for the next 5 samples, right? Like it could be anything. If you want, you can add different types of attachments. You can add a report image, or a file attachment, or a file link, right? Like it could be a totally different link to a different system where you are working on a specific project. And I can click submit, and now the Q note is added into the system. So if you notice, right, like the performance of the system is also pretty quick. It took me less than a few seconds to add a Q note, or view a Q note, or to generate a report as well. So that's how fast the system is. And another topic that I want to cover is quality scan. So we have another add-on module called quality scan as part of QDM Web QI system. I can quickly select quality scan, and now it shows me the home page of the quality scan, right? So I can quickly type in the part over here. So let's say if MBK block, or let's say if I can just type in block, right? I can type in block, and it filters to that particular data source. So I can click in MBK block over here, and now what it does is I can see a page where the samples were uploaded into the system, and also the list of features. But on top of that, you have an interactive 3D CAD viewing capability, right? So I can come over here, I can see what features were measured. Let's say if I'm interested in the diameter features, I can click over here, and it'll basically tell me what that feature is, right? So let's say if the diameter feature is something that I'm interested in, I can click that feature. So now what it does is you don't even need to know the feature name. You can simply look at the CAD and then select features, and now it shows you the last 50 run, right? Like 50 samples over here. But some people say, you know what, I want to make the CAD a little bit more bigger, right? So I can come over here and I have different layout types as well. So I can click in a different layout type, and now it makes the CAD as the primary focus, and it shows me what the statistics are. So we have different layout options, and it shows me different statistics as well. So let's say if a user or a quality engineer, I'm doing some kind of root cause analysis or some kind of greenbelt project, I can also add a Q note from the system, from the quality scan system as well. So I can click in the plus sign over here, and it brings up the Q note feature, very similar screen that how we showed in QDM QI system. You have the same options of review, action, kappa, or results. So let's say if I'm selecting kappa this time, you can attach the screenshot, and you can also send emails from the system itself, where you don't have to take a screenshot, put it in your own email server, and then send it back again, right? So you can do everything from the system. So now over here, I can again send emails to a couple of people, and I can click submit. Oh, sorry, I need to have message. So I type in monitor the next samples, right? So I can click submit. So now I can add, so now what I did is I can do a root cause analysis from both of our systems, and it provides very similar results, but then it shows the data in a much different way, right? Like one, we have like a specific template. You can comb through the number of report pages, or we have this 3D CAD capability where you can see the run of features that had happened for the last 50 samples or 30 samples that was measured in the shop floor. And you also have the capability to rotate or zoom in the part as well. So that's the quality note feature, as well as the quality scan feature that we have in QDM Web QI system. Now back over to you, Trev and Alex.
Thanks, Bonton. So with Metrolog, you can use more than just like a PH20, and you don't have to use a specific type of CMM. Because we have a universal platform, we're able to work on any type of principle of CMM with really any type of manufacturer and whatever head that you're really looking to use on there. So you're not just using the PH20 or the Revo, but maybe a PH10 or maybe one of the Zeiss indexing heads, maybe one of Hexagon's heads. We're able to interface with those, as well as portable devices like ARMs and 3D scanners and laser trackers. This kind of bridges that gap of understanding and correlation between all of your hardware, and ultimately everything's able to go in and be utilized fully in the input into DCS and QDM and 3DCS. And we really do this with universal connections. So we work really hard to have good relationships with all of the major manufacturers, and we aim to have direct connections to these machines. And so generally we're not working through an I++ server, but rather we're talking in the language of that controller. And that way we're able to get the most performance out of that machine, be able to get the behavior that's predictable out of that machine, and get really accurate use and utilization out of that. So we're getting the full range of capability with that, and then you're still using the same language. And so if you take from one measuring principle machine, maybe a horizontal machine that has a PH10, you can translate that over to a bridge machine that has a PH20, and with some minor changes, you're able to use the same routine, all the same inspections, and that whole gap of correlation between your machines is starting to get more and more closed, and you're able to start to understand the difference in your hardware.
Thank you, Alex. Thank you, Trev and Bonton. I appreciate it. All right, Alex, I'm getting a little feedback from you, so just be mindful. All right, well, thank you so much. I appreciate that. Let's take a few moments to answer some questions. Trev, do you mind turning on your webcam? Thank you very much. Excellent. So we had a couple questions come in. I've organized them a little bit to try to separate them. The first is, do I have to manually create or adjust all of the program steps? I believe that's referencing the CILMA program that you showed. This is directed towards Treb.
Yeah, so I can answer that question. So we don't have to manually create all the steps. So we have some tools. We have a tool called, I'm trying to remember the tool, IPP, that allows you to do all the movements between all the features automatically. And then there's some other functionality that we can use to create the measurements and the movements around the part and things like that. So there's some things that we can do automatically. There's some things that we maybe want to do manually. So all the moves we can handle and have the movements. I was just talking about how we have the automatic avoidance. So that's kind of part of that functionality as well. So we can just turn on automatic avoidance, and then we just select all the features that we want to measure, and then it kind of figures out how to avoid the part and avoid fixturing and things like that automatically.
Great. So this other question I pulled forward, I think it references the same. Is it possible to generate trajectories with collision detection with the 5-axis method when you are defining your feature? So for the program, it looks like when you're defining your features for the program on the 5 axes, can you change the trajectory of the probe?
Yeah. So we can control the probe trajectory. So we can control the orientation that we want the probe head to be. We have a lot of tools that we can do that visually, or we can type in specific values if we want the probe head to be offset, 25 millimeters or something, or if we want to reach the probe through the other side of a counter bore, for example. We can do things like that. So we have full control, and we have visual tools that we were kind of looking at earlier. So we were looking at that, just to show a go-to move, but we can use those same tools when we're doing a measurement. So maybe we need to reach around or maneuver around a fixture to measure a hole, and we can't have it perfectly centered and things like that. So we can control where the probe head center is and some things like that.
Okay. All right. I got another question in from the same user. I'm going to address this one right away then. With the 5-axis heads, with the head touch method, is it possible to specify a head angle at the start of measuring the feature and a different angle at the end of the feature? So can you manually set the angles from the start of measurement and the end of the measurement?
I muted myself. So for that, it kind of depends on what measurement type you're doing. So for example, if you're doing a section measurement and we're doing what's called a guide rail with like a 5-axis head, so we can set a specific orientation for the head to be when we start that guide rail measurement type. So we can start maybe the probe head's angled towards the left side of the part, and then when we measure around from the left side of the part to the right side of the part, we want the probe head to be offset towards the right side of the part, so we can set those directly as part of a guide rail measurement. And then we also have the ability, we can actually individually customize each individual probing. We could actually change or go in and edit each individual probing point or each individual move point and set the specific head angle that the head is for any specific position or any probing or the path for 5-axis scanning and things like that.
Great, thank you very much. I'm going to pull one more question for the Metrologic team, and then I'm going to do a few for Bonton. So I have a CMM already. If I wanted a 5-axis, would I need to replace my CMM?
I can take that one. No. So a lot of ways that people get 5-axis is by retrofitting a CMM. That's something that Metrologic can do, or one of our partners can do, and all we'll do is we'll kind of assess what you have on there, where your scales are, and you would just get a new controller, you would get a new probe head. We discuss like what kind of processes you're after. So, maybe a Revo retrofit will be best for you, or PH20, and then kind of what other items that you need there. But it's a great way to take a old frame that's still good and give it new life, and you up your accuracy and your throughput out of that machine, and then you also aren't hiring more people to run extra machines.
I would think it might be a little more cost effective to retrofit than to buy a brand new machine too. All right, so for Bonton, Here's a good one. We have our own quality metrics we adhere to. Can I customize my metrics in the database? By database, I think they're referencing QDM Web.
Yes, you can have your own metrics. So let's say if a certain company uses CP and CPK, and we can customize it to CP and CPK. Or let's say if a company, let's say if you want just the PIS scores, or if you just want the PP and PPK scores, we can do a whole lot of customization. So it depends on each customer. QDM Web is customized to each customer's needs.
Thank you. Yeah, I'm getting a little feedback, Bonton. Can you just turn down your system audio output? And that might help with that. Okay. Well, I have Bonton here in the QD system. So I think they're referencing the QDM system. Is it limited to 10 samples? And does it have to be the last 10 samples?
No, it's not limited to the 10 samples. So you can, let's say if you want the last 100 samples, or let's say if you want 10 samples from a certain time range, and then you want to select another set of 10 samples, yes, you can do a different set of 10 samples. It doesn't have to be in a specific order. You can pick and choose your samples you want.
Okay, we have a follow-up question for the Metrologic group. With the head touch, is it possible to choose between 3 or 5 axis movement between points when I'm measuring a big hole, for example?
Yeah, so we can do that. So I was talking about earlier how you can customize each individual point. So we can measure a whole feature as 5 axis. We can measure a whole feature as 3 axis and switch back and forth. So maybe there's some things we still want to measure as 3 axis, maybe plane or something like that. But we can manually change or customize each individual probing point or each individual position move and make it a 5 axis or a 3 axis or even a 2 axis probing. So we have the ability, you know, maybe a couple of points inside of a circle or something we want to measure as 3 axis for one reason or another. We can change the probings and change the method of the probing for each individual point from 3 axis to 5 axis or vice versa.
All right, thank you very much. This is one for Bonton. I need to provide a lot of reports at the end of the week. How long does it take to make a report? And is there a way to get a lot of different reports for the week all at once?
Yes, you can. We have something called as the auto publish feature, which runs instantaneously whenever a new sample is uploaded. And you can set it up in a way that these reports can be sent to your email. So it's a push-based system. We can set it up in a way every end of the week you can get those reports, or on a daily basis you can get those reports as well. The reports are generated almost instantaneously. It doesn't take you a lot of time to generate those reports.
Thank you, Bonton. All right, so here's a follow-up on the samples question in the QD system. So they're referencing QDM. We have a lot of different types of measurement devices. Does it matter which device we're using? Can we connect all of these devices to the same, or do we have to get additional add-ons?
No, so you can connect to whatever system that you want. So let's say if you're using Hexagon or Polyworks or Metrologic or VeriSurf, we have something called as data grabber, which grabs the data from its native format from all these systems. And internally in QDM Web QI system, we convert it to a format that's readable for our system, and we do all that processing in the backend. So in short, you don't have to change anything from the output file that you receive from these systems. We do all the crunching, and the background stuff is being taken care of in the QDM Web QI system. So to answer your question, no, I mean, you can use any system that you want, and QDM Web QI system is actually compatible to all these systems.
So it's a universal, similar to what Alex was talking about with Metrolog as well. Wonderful, thank you. So here's one that's pretty close to home. I'm a 3DCS user, which is, if you're not familiar, 3DCS Variation Analyst is DCS's CAD-based simulation tool. It's integrated into CAD and simulates assembly processes, tolerances, GD&T, and PMI. Is there a way for me to get the the data from QDM instead of using instead of using the design data?
Yes, there is. So there is something called as a connector between the 3DCS and the QDM Web QI system. So within the 3DCS software, you can download the real-time data that's coming from the QDM Web QI system, and it downloads data. Instead of using simulation data, you can use the real-time data from the QDM Web QI system. So to answer your question, yes, there is a direct connection from the 3DCS software, very similar to how Trep showed you today from the Metrologic to the QDM Web connection. We have a very similar connection between 3DCS and QDM Web QI system.
Fantastic. Well, I'm afraid that's all the time we have for today. So thank you everyone for joining us. Please keep an eye on our newsletter and our website, as we are going to be announcing our next webinar soon, as well as more information coming out for our user conference, which will be later this year in September in Troy, Michigan. It'd be great to have you join us, where we'll be showcasing not only customer stories and case studies as well, but we'll also be showcasing new software updates, features. We're hoping to have our friends from Metrologic join us, and we will be having some workshops and training opportunities. I will include some information about that in the follow-up email, which you'll receive tomorrow morning, which will have the recording of today's session, the presentation that Alex and Treb showcased, as well as some additional links. For example, that previous webinar recording I spoke of for using 3DCS data and the connection between 3DCS and CMM Metrolog. So once again, I want to thank our guest presenters, Alex and Treb from Metrologic Group, and Bonton. Thank you for being here from our QDM team at DCS, and of course, all of our customers and guests here in the webinar. We hope to see you at the next one.
Thank you.
Thank you.
Thanks, everyone.
All right.